Hey there, Ravens, back again. We're going to talk about Thomson's Plum Pudding, Atomic Theory, Part 2. All right, J.J. Thomson was credited with discovering the electron in 1897. He did this through experiments with what is known as a cathode ray tube, also called a Crookes tube. Cathode ray tubes, just let you know, older technology. If you ever seen one of those giant, huge, heavy, bulky TVs with big backs to them, don't see many around anymore. But they operate with what was called a picture tube. And that picture tube was, in sense, a cathode ray tube. All right, so here we go. The way it was set up is there's some source of an electron, meaning a large power source voltage battery, and electrons flow out of the battery through the positive side, and here's just a metal plate and a phosphorescent screen, meaning that in the presence of energy it's going to glow. And here's the negative end, and electrons continue to flow through the wire there, but there is no wire connecting either side here. Okay, so we have these, they're called cathodes and anodes. Okay, so let's see how it looks. All right, so in Thomson's experiment, what he did is if you pass a power source through, makes the beam move from the positive end to the negative end. Okay, and what Thomson noticed was that if you take a magnet and put the magnet, you could deflect the beam or draw the beam toward the positive end, the positive pole of the magnet. So therefore, whatever's moving across that beam has a negative charge, and it's movable, obviously. Okay, so here's a video where you can see the actual thing. Let me get my cursor. There it is.
To demonstrate a Crookes tube, a cathode ray tube, we need a high voltage power source, such as this one. We need the Crookes tube, which has a metal cathode, a metal anode, a screen that has been coated with a phosphorescent material that gives off light when struck by electrons, and a bar magnet. As we turn on the screen, we notice that the electrons are emitted from the cathode, and as they strike the fluorescent screen, we're able to see the cathode ray, this stream of electrons illuminated. We can use a magnet to show the deflection of that stream. Here we can see the electrons being deflected by the magnet. The cathode ray moves upward. If we reverse the magnet, we would predict that the beam would be deflected in the opposite direction. And we observe that the beam is deflected downward.
All right. So, summarizing, Thomson's model of the atom, what he believed it looked like. He said that there were negative electrons and that these electrons could move across empty space because a cathode ray or Crookes tube is basically a vacuum, meaning there's no matter inside the glass tube except for that phosphorescent screen. So he described the atom as being like plum pudding. You may want to think about it like a chocolate chip cookie, that the cookie part is positive with removable electrons, chocolate chips, or like you could pick the pieces of plum out of the plum pudding. All right, that's it. That is Thomson's experiment and how he developed his model. We'll see you soon in part 3.